All right, so this unit we are going to learn about counting, which I know sounds like something that would be silly to be learning how to do in your senior year of high school, but that is kind of the theme of this unit. It's counting and coming up with ways of counting things quickly. Okay, now today's lesson is going to be about sets and set notation. It is basically a vocabulary lesson. Okay, so it's all about learning this different vocab that you've never heard before and just kind of working with that. Okay, so it's going to feel very vocab heavy because it is. Okay, so first off, we need to talk about what a set is. So a set is a collection of objects. Okay, and they could be anything. Sometimes we just use like letters or numbers, but they could really be anything. You could be talking about a set of books. You could be talking about a set of people. So it's a set of objects. Okay, each of the objects in the set is called an element of the set. Okay, if an element, call it X, is in a set, which we will call A, then you use this notation. So X is in A, right? So that's what that symbol is. It looks kind of like a backwards capital E, right? So it's just sort of a weird sort of looking symbol, but that's what that means. Okay, if X is not in A, then it's the same thing, but with a little slash through it, like a no smoking symbol. Okay. All right, so for example, right, if we were to say, all right, we have a set A, right, and I'm going to make it, so the way that we write sets, we use braces like this, okay, and then you just list whatever's in it. So say we want our set to be all of the odd positive numbers, so 1, 3, 5, 7, 9, and so on, right? So that's what our set is, okay? So if that's our set, then we would say that, oh, the number 33, right? 33 would be a member of this set because it's an odd positive number, right? So we would say that 33 is in set A. Okay, but we would say something like 40 is not in set A because that is not a positive odd number. Okay, so pretty simple. We name your sets usually with a capital letter. And then when you say your elements are either in the set or not in the set. All right, so that's one way that you can write a set. You can list out the elements. But another way that you can write a set is using something called set builder notation. Okay, so for example, right, these two things are the same. You could either write set V is A, E, I, O, and U, or you could define it using this notation where you're basically writing it out in words. So you're saying that V is all the elements X such that X is a vowel in the English alphabet. Okay. Another example down here, right? So this kind of walks you through exactly how you'd read this. It's in little braces like this, so we call it the set. So it's the set of all X values such that X is greater than 0. Okay, so that's just another way that you could define it. Something like this, if you just wanted X, like all the numbers that are greater than 0, trying to make a list like this would be virtually impossible, right? Because that would include all the fractions, all the decimals, all the square roots, right? All those different numbers, trying to just list them all out would be really difficult. So it's a lot easier to write them out in either symbolic form or in word form. Okay, so then we have a special set called the empty set. All right, and the empty set is exactly what you'd think. It's a set with nothing in it. Okay, it's donated by this symbol right here. It's like a giant O with a little slash through it. All right, a set is considered to be non-empty. So you don't say it's like a full set, you call it a non-empty set if it has at least one element in it. So it's empty if there's nothing in it, it's not empty, non-empty if there's at least one thing in it. Okay. All right, then when we talk about sets, we say that two sets are equal if they have exactly the same elements, though they don't necessarily have to be in the same order. Okay, so for example, if I had set A, and I said set A is the numbers 1, 2, and 3, and then I have set B, and set B is, say, the numbers 3, 2, and 1, right? It's the same numbers, not in the same order, but that's okay, right? So that tells us that A is equal to B. Set A is the same as set B, even though they're not in the same order, which I think is kind of obvious, but it's a thing. Okay, so new vocab word. Set B is said to be a subset. So a subset of A if every element that's in B is also in A. Okay? And then this is a notation that you'd use for that. B is a subset of A. Okay? So basically all of that's saying is that, you know, if you're every number that's in B is also in A, it's a subset. So like if you like took a whole set A and then you just took some of the things out of it, right, and called that set B, then that would be considered a subset because all of the things that you took came from set A. Okay? So for example, right, set A is 1, 2, 4, 5, 7, 9. Set B is 2, 5, and 9, right? So 2 and 5 and 9 are all in set A. So we'd say that B is a subset of A. But set C, 5 is in there, 1 is in there, but 3 is not in A. So it is not a subset because not all of its elements come from set A. So we'd say C is not a subset of A. Okay? And when you look at these symbols, it kind of is like a greater than or less than or equal to symbol, right? Like, see how it looks a lot like a less than or equal to symbol? It's sort of the same idea. And if this were a less than symbol, right, you'd be saying that set B is smaller than or equal to set A. And that's essentially what we're saying here, right? It's included in the same elements and it's just smaller than A. Okay? A set is considered to be proper. Okay, so a subset is considered to be proper, so a proper subset if it's not equal to the original set. Okay, so this symbol we could also use instead of this one. Notice it just loses the equal to on the bottom, right? So you could say that set B is a subset of A, or you could say B is a proper subset of A because they're not the same thing. Okay, so like technically speaking, right, when we had this example up here, technically I could have said that B is a subset of A because technically it is. And we could also say that A is a subset of B because, again, technically it is. But it's kind of stupid to talk about them being subsets when they're the same thing, right? So we say that if they equal each other, they are technically subsets of each other, but we call it a proper subset if they're not actually equal to each other. Okay. All right, the set of elements not in set A is listed as A to the -1, right? Or I'm sorry, not A to the -1, A prime is how that's pronounced. You call that A prime. Sorry, that was silly. Okay, so for example, if set A was, say, there we go, 1, 3, 5, 7, 9, right, and so on, right? Then set A prime would be everything not in that set. So honestly, though, I can't think about how to write that out. Like, how would I write that out in numbers? Because that would include all sorts of fractions and decimals and negatives, right? So I'd have to write this in set builder notation. So A prime would be all values of X such that X is not a positive odd integer, right? Those would be two opposite things. Together, they encompass all of the numbers, but this is all the things that are not in that one. All right, so now these next things, okay? So the big things that you're going to need to know on this page, I think the things that are not obvious is the subset thing. That's going to be important. And then these next two things, okay? So those are kind of the big things to keep your eye on, okay? So the next thing that we're going to talk about is the union of two sets, okay? So the union of two sets is the collection of all the elements that are in either set. You don't write anything more than once. So the union, it's like when two people get married, they move into a house together and they take all their stuff and mix it together, right? But you don't keep two of anything. You don't need to keep two refrigerators or two blenders, right? You get rid of anything that you have an extra copy of, you only keep one, but it's putting them all together, okay? So for example, if I had the set, like, so if set A is, let's just go with 1, 2, 3. And set B is, we'll go with 3, 4, 5. Okay, then the union of the two of them right? And the symbol, the way that you would write this out symbolically, is you would write A union B, U for union, right? So the union of those two sets would be 1, 2, 3, 4, 5. So it's just all the numbers in both sets put together in one place. And even though the 3 showed up in both of them, you don't write 3 twice, you only write it once. Okay? So the union is when you take two groups and you mix them together. Okay? Now the other thing is the intersection. Okay? So the intersection of two sets is all of the elements that are in both. In other words, it's where they overlap. Okay? So using the same sets, right? So using those same sets from up here, right? If I wanted to know what the A, and then it's like it's this symbol but upside down. So this one is like a U for union. This one looks like an N for intersection. So the intersection of A and B would be the things that they have in common. And the only element they have in common is 3. So it would be the set 3. And that's it. Okay? So again, those are the 3 biggest concepts that you need to make sure you pay attention to. Subsets, right, which is when some of the elements are used to form another group. Okay, union, which is the collection of two groups put together. And intersection, which is where they overlap each other. Okay, if we have two sets that do not have any elements in common, so like if there hadn't been a 3 in this one, so there's nothing that they had in common, right, then in that case, we call them disjoint. So they're disjoint because they don't have anything in common, and you would say that the union of those two sets would be empty, right? Remember, this is the symbol that we used back up here for the empty set. Okay, so we would say that the union of the two of them is empty. Okay, so that is a lot of vocab, and that is just basic stuff that you kind of need to be familiar with as we're working through this unit.